Hello guys, this is Sudham Cap. Welcome to my channel Physics for Fun. In my previous video, I have described you about polar coordinate system in which I have derived you the length element in polar coordinate system, that is here, and also derived the area element. And we have also shown you how to derive the area of circle as well as area of disk using the polar coordinate system. Using this kind of symmetry will make your life really easy. So in this video, we will dig deeper and we will find if any object moves in a circular fashion or in a circular trajectory, how you can find the velocity as well as acceleration. Well, we will use the polar coordinate system to find the velocity as well as acceleration, and really using this kind of symmetry will make your life too much easy. You don't have to think about anything and every result is going just in front of you. So here we have learned so many things like r hat and theta hat for this basis, and we have seen that how the derivative the derivative of r vector as well as r hat gives you the new kind of things. Now in this video, with the help of velocity as well as acceleration, I am going to find the equation of motion of two systems. It is a very good system. It is simple pendulum, and here is a mixed problem. Okay, so it is a little bit harder. I am going to derive the equation of motion using the framework called Lagrangian. So in this video, you are going to understand how Lagrangian also work, and also understand that how this kind of symmetry, how the polar coordinate will make your life really too much easy. So let's proceed with this thing. Well, let's proceed to find the velocity, how we can find the velocity. Now here we have two-dimensional object, and now again I can write here r vector in terms of Cartesian system, that is x hat and y hat. Well, in my previous video I have always uh, shown you that x is equal to r cos theta and y is equal to r sin theta, and I am having this is x hat and this is y hat, and I am having this one. So these guys can be borrowed from here, because here is always x hat is this one and y hat these guys. So just let me take this object from here to there. Well, now what I'm going to do is plug all these things here. So now I can write and then r sin theta r hat plus cos theta theta hat. Well, this is very simple. Now what you can see is that r cos theta multiply with this thing as well as this will multiply this thing, so it will become r cos theta sin theta with negative sign. Now here you can see that r sin theta and cos theta with same thing, so these guys will cancel out each other. Now with what I am left with r cos theta r hat r sin square theta r hat. So now we can take common r hat, and then we are left with cos square theta plus sin square theta, which will give you this thing, and I am left with this one. So I have shown you that I can write r vector in terms of the whole polar coordinate system like this thing. Well, to find the velocity, now I have position. Now I want to find the what would be the velocity in the polar coordinate system. Well, to find the velocity, I do have to do nothing but this thing, dr by dt. Well, one more thing I'm going to adapt in this video, in this whole video, that if I am derivative any kind of quantity, suppose I have quantity q and I want to write the derivative with respect to time, so I'm going to just represent it as like q dot. Okay, this if you have seen, if you will seen anything with to the power some kind of a dot, you will see that it is nothing but time derivative, one single time derivative. And if I am writing this like second derivative with respect to time, I will put two dots here. Now with all this thing, I'm going to write velocity in terms of this guy, so I will write it like this way. Now what I have to do is chain rule. So I am assuming that my r can be varied with time. So what happens is first I derivative this thing, and again I want to derivate this guy here. Well, now r hat is not problematic, but what happens to this one? So I can write it dr by dt can be written as dr over d theta and d theta over dt. Now in my previous video I have already described you what will give you. Now dr hat over d theta is going to give me my theta hat. So what I'm going to write it as, this is my theta hat. Now d theta by dt is going to give me theta dot or omega. So my velocity is nothing but r dot r hat plus theta dot theta hat. Hang on, this is my r, okay, because now here it is r. So this is the thing you have seen in whenever you are solving some kind of if any object is moving in a circle, what happens, you will write immediately v is equal to r omega. Okay, so without any kind of understanding of any physics that how v is equal to r omega comes, we have used the simple mathematical tool to just write my Cartesian system in terms of a polar coordinate system, and from here I simply derived v is equal to r omega. Now this guy represents here the translation motion. So this velocity consists, one is translation motion and theta is angular motion. So what happens is that here if it is a center, now if you are progressing this one or this one, this r hat represented that you are going this side. Now theta hat is representing that you are moving like this. So when any particle, any object is moving in a circular path, v is equal to r omega is valid. And now if the radius of the circle is varying, so this will become relevant, that r dot is also varying. So you are having translation as well as rotation in a single frame. Now I have to understand how we can find the acceleration. So acceleration is nothing but r double dot or simply dv over dt. Now what is the velocity here? Velocity is nothing but this one, so I'm going to write it as r double dot, just chain rule, first derivative with respect to time and then this with respect to time, so this one plus, now here three quantities. First I'm going to write this one, theta dash, plus r theta double dot theta dash plus r theta dot this one. Now I have to now here what happens to r dot cap. R dot cap is going to give me nothing but theta hat theta dot. Okay, I simply have derived here what happens, theta dot theta hat. Now I have to derive what will happen to this guy. Now this I can write it as d by dt of theta hat. Okay, now what is my theta hat? This is nothing but dr by d theta is going to give me theta hat. Okay, now I have to take time derivative of this guy. Okay, so it will become nothing but this term. Well, from here I can write it as d over d theta, now d theta over dt. So what is going to become is d theta by dt gives me this one, and now this is going to give me this guy. Well, I know what is my dr over what is my r hat, so I can write it as here I have to borrow from well, what is my r hat? So let's first derivative with respect to this guy theta, so it will nothing produce the theta hat cos theta y hat, and again let's derivative once more, d2r hat over d theta squared is going to give me cos theta x hat minus sin theta y hat. Now here you can analyze this is nothing but simply r hat minus of r hat. Okay, so what I have derived here that it is nothing but r hat theta dot. So the whole thing has given me that theta dot is nothing but minus r hat minus r hat theta dot. Now I'm going to use this guy here. Now, well, here is my acceleration, this one. So I can write acceleration is equal to r double dot r hat plus r dot. Now r dot is going to give me theta dot theta hat. This guy gives me nothing but, now here I can write it as r dot theta hat plus r theta double dot theta hat minus r theta dot. Now theta dot has given me minus theta dot r hat. So this plus becomes minus. So minus theta dot r hat. It is a little bit too much mathematical, so please don't get bored. You have to do all this stuff. Now see here, it will become 2r dot theta hat plus r theta double dot theta hat minus r squared. Sorry, it is not squared but theta dot squared r hat. Now I can write it as this r dash and r dash I can write in a very funny thing. And well, theta dash and theta dash, now here theta dot now this is my acceleration. Okay, so here I can see here now the amazing thing is going to happen. So what kind of amazing thing that can happen, I will let you know. Now what is this? You are seeing that here it is radial direction of acceleration and here it is tangential direction of the acceleration. Now here you can see that this r double dot is going to give you nothing but translation acceleration. Okay, so this block is constant to move in something, so it will correspond to constraint equation. Now what happens to r theta dot square? What is this? Now if you are remember that if your particle is moving in a circle, what you're going to write? Now F is equal, due to centripetal force, you are going to having mv square by r, and you are told that if F is nothing but ma, so what happens is that mv square by r, m gets cancelled out. Now v square can be written as r square omega square by r. Now it is nothing but r. Now omega can be written as theta dot squared. So my acceleration is nothing but r theta dot square. So this is the centripetal force, and the centripetal acceleration can be given by r theta dot squared. So what happens now? Here you can see that r theta dot square. Now this negative, what does this negative sign do? This negative sign sign manifests that your object when moves in a circle, the centripetal acceleration is always inward, because you know that this r hat is always outward. Okay, so the negative signs make this sign reverse. So here you don't have to think anything, and you just derive the centripetal acceleration without doing any kind of physics. And it is true that acceleration in radial direction, the acceleration involves also in tangential as well as the centripetal acceleration. What about this guy? This corresponds to tangential acceleration. Now this is going to give you the Coriolis force. Okay, now this kind of forces or acceleration can be given, you will see in a gyroscope motion. So in this video I am not going to describe you much more about the Coriolis force, but in my later video I will give you some tutorial about what is gyroscope motion and a detailed analysis of gyroscope. So just forget about this thing. Well, now here you can see that what this guy is doing here. Now if you are remembering that torque is equal to I times alpha. So what alpha is nothing but d omega by dt. So torque, if any object is rotating, that produces some kind of a torque. Now torque I can write is r cross f, and here it is I alpha. Just let me write here. Now suppose this is perpendicular to all these things, so now force can be written as I over r. Now if I am having, I can be defined as mr squared. So if it is mr squared over r, now it is my alpha. So F is equal to ma. Suppose I am equating with this kind of thing in Newton's second law, so get cancelled out. Now r alpha. So A is equal to R alpha, and R alpha, because alpha is d omega by dt. Now omega is d theta by dt, so I can write it as d theta over dt square. So hence I can write it as like this. So this is nothing but a angular acceleration, that is r theta double dot. So this angular acceleration is producing because your particle is moving in a circle and your theta dash is keeps on varying with time. So the angular acceleration is produces because of this thing happens. So you see, using the polar coordinate system, it will give you what happens to the acceleration in a non-inertial frame, because when you are going to study the rotational things, you have to keep mind the centripetal acceleration, and these guys are producing because you are not in an inertial frame, but you are such a frame, the frame is accelerating. So this guy, the accelerating frame is called the non-inertial frame. Okay, and if the frame is not accelerating, it is called an inertial frame. So whenever your frame is your frame's velocity isn't in uniform but changes with time, so these kind of funny things you are going to see. So whenever you are forced to, and you are forced to study the rotation of any object, you have to always move towards the polar coordinate system. And the polar coordinate system gives you a powerful tool. Without understanding any physics, you can easily write the equation of motion for any kind of object. Now for this moment, I am going to take a very nice example of simple pendulum. So how you gonna write it? So suppose it's a main position where the object is there, and suppose the length of this pendulum is L. Now in simple pendulum, you have already seen that the length is not derivative of time. It means that the length is not going to become large or shorter. So I can write it as L dot is nothing but 0. Now you know I have described that I am going to use the Lagrangian. So the Lagrangian is defined as kinetic energy minus potential energy. Okay, now I have to figure out what is the kinetic energy. Well, if you will look closely, what happens that after some time, if you just this object is going to move like this. So what happens is that it is almost like it's moving in a circle. So if it is moving in a circle, I am free to use the what you call polar coordinate system. Now I know what happens is polar coordinate system, because it is r dot r hat plus r theta dot theta hat. The velocity in polar coordinate system is going to give you this one. Well, now kinetic energy is nothing but half mv squared. Well, I have already described. Now here r dot, what is the r dot? R is nothing but from the radius of this object. Now the radius of this object is given by L, and this L is fixed. It is not changing with time, which I have given you here. So with this help of this thing, my r dot will become like, so V is become, this guy is 0, L is, R is replaced by L, and it is theta dot. So I can write it as kinetic energy is going to give me, so this square becomes L square theta dot squared. Now theta hat, it will become like this, and it will be just any unit product. So I don't have to do anything. Well, just put it here, half m L square theta dot squared. Now what would happen to potential? To analyze the potential, what I have to do is here like this. Now this is the true length of this polar system. Now it has just moved this one, so I am analyzing everything. So this is my origin. Suppose this is my origin. Now how much it got here? So from here I can write it as the whole length is this one, and this is my angle theta. So for this I can use cos theta, and I can write it here. Cos theta is nothing but the base and the base is for here this triangle, base is this one, this is watt over the hypotenuse, that is L. So watt can be given by L cos theta. So this here I have found L cos theta. Now whole thing is given by L, so the potential can be written as, because you know the potential is nothing but mgr. Okay, now R has become this guy, so this will write as mg L, if I can take common, 1 minus cos theta. Some people also prefer to write negative sign, so I don't prefer to write negative sign, so I just make it positive. It will not make any sense because it is the way we choose the reference or our reference system, that what is my reference point. My reference point is this one, and I have made this, whatever you, if you are going upside, it will make you positive, and if you take the reference point from here, if you go down this one, you can use the positive way. Okay, negative sign. So there is nothing like, it is a very trivial system. So my Lagrangian is this one. So L is equal to half ml square theta dot square minus mgl into 1 minus cos theta. Now you know the Euler-Lagrange equation, that if you are having some kind of a coordinate, now what are the coordinate which is changing? The thing is that the changing is that theta dot. Okay, L is fixed, L is not changing. The changing is this one, theta dot, and we take the time derivative of this guy, and this will going to provide you simply this one. So this is nothing but Euler-Lagrange equation. Following this one, I have to first derive what is this thing. So del theta dot, now theta dot is independent of theta, so whenever you are derivative with respect to theta dot, all the theta will just vanish out. So I have only single point here, theta dot, so it will going to give me ml square, because the derivative of this theta dot gives me 2 theta dot, 2 to cancel out, and here we are left with theta dot. Okay, now what happens to del by del theta? Well, I can write it again, it will vanish out, and this guy will going to give me minus of mgl sine theta. You do this, it is a very simple task. Let's take the time derivative of this guy. It will going to give you ml square theta double dot. Okay, now I have to equate with this thing, and I'm going to equate with mgl sine theta. Now 2 L, 1 L is cancel out. Now theta L is going to give me minus g by L of sine theta. What happens is that when your angle is so small, because you have already know that whenever you have simple pendulum, the angular displacement must be small. Okay, otherwise if it is not small, it will depends on this kind of a sine function, and you have to uh, make it a Taylor series expansion, and there are so many terms which is the correction term is going to have involved. So I'm assuming that if your angular displacement is too much small, it means that your theta is so much small, then I can write sine theta approximate with theta, and you are left with nothing but only theta. And now this will give you the omega. Omega, it means a time period, so omega can be written as omega is equal to square root of under root g by L, and this is what you get if you write the equation of motion using the Newton's formulation, that you are equating each and every force with respect to ma. Now here you don't have to think anything. You just wrote the velocity in polar coordinate form. You even didn't think about to write the velocity for this system. You just write the formula, and you have calculated the potential, and from this framework, this gives you the same equation what you got using the Newton's second law. So you need Newton's second law. While you are using the Newton's second law, what happens that you have to use some kind of a coordinate system, that is x and y, and you are using system that this is my mg, this will become mg cos theta, this will become mg sin theta, and this mg sin theta equate with ma. So for this system, the ma is equal to mg sin theta. Okay, it is a very simple task, but what happens if I am taking some kind of a bizarre equation like that. Suppose I have to solve this system, then what happens? Where this object is can move this way as well as this way, and this object is moving like this also. So here, the suppose this length is my L and any displacement occur here, suppose this is my X or suppose this is my R, so the total length will be L plus R. L is constant but R is changing, so the velocity, the time derivative of this L is going to vanish out, but R is keeps on there. So R dot is there. Now your life has become really hell. But I am not going to use any Newton's equation, so I am fine. I have the framework. I have the very amazing framework because I don't have to do anything. I have to write half mv squared, and v is nothing but r dot and r theta dot theta hat. Simple. Now, well, I am sorry because I have used the displacement here r. Suppose you can use the x also. Okay, it's nothing. It is not going to. It won't give you any kind of problem. So let me just write here x. So I am assuming that my r is become L plus x. L is the spring length and x the displacement it is having. So r dot is going to give me simply x dot. Theta dot is going to give you nothing but just theta dot. So my equation of motion will become kinetic energy will become mv squared. What is my v? V is nothing but this r dot squared plus r squared theta dot squared. Okay, well, what I can do is here r dot is going to give me h dot squared. Now r squared is nothing but L plus x squared, now theta dot square. What happens to the potential? Here two potentials are involved. One potential is due to the spring, so the potential is nothing but half kx squared. X means the displacement, so the total displacement is L plus x. So I am going to write it as L plus x squared. And again, one more thing is that just from the simple pendulum, how much it has raised from here. Okay, so how much it has raised from here, I can write it as with positive sign mg L plus x into 1 minus cos theta. If you have some doubt, please let me know in my comment box. I will do this thing. Well, now I can write the Lagrangian for this framework. So I have my half m x dot squared plus L plus x squared theta dot squared. Now here the negative sign with and this guy. Now here you can see that the Lagrangian depends on x also, x dot also, theta also, and theta dot also. So you are having the two equations because del x is going to give you this guy also, two independent equations of motion, and this here, the angular term as well as the linear term. Okay, so you don't have to do anything, you just have to derivative with all these things and you will get the result. Now what happens if I am derivative with respect to x dot? Now where the x dot has appeared, there is only one here only. So what is going to give me, everything will become 0. The time derivative x dot is going to give me mx double dot. Okay, now what happens to del Lagrangian over del x? So where the this happens, now here only and this only and also this one. So too many places where I can write it as L plus x theta dot squared. Well, do it by yourself, don't rely on me for derivative also. L plus x, and this guy is going to give me negative of minus cos theta. Now we have to equate it. So what I'm going to do is mx double dot is going to give me L plus x theta dot squared minus k L plus x, and one more equation that is here. So it is a very amazing equation, but very much long equation. Okay, now let me write the angular term. What happens to angular term? Well, this guy, what is going to give me? Theta dot. Theta dot is involved here and nowhere. So theta dot is going to give me theta dot. Let's take the time derivative of this guy here. Now the time derivative is also derivative this guy also. So first let me derivative this one, 2 ml x, sorry. Now what happens is the x dot and theta dot plus, again it will going to give me now derivative is this thing. Well, it will going to give me theta double dot. Now I have to derivative this guy over here, sorry, only theta. What is going to give me is, where is the theta? Theta is involved not here, just here. So it will give me minus, minus becomes plus, cos theta has a derivative, gives me minus of sine theta. So it will give me minus mg L plus x sine theta. Anywhere it will appear except this thing? Well, nowhere. So now I have to equate this and this. So what I am going to write is as m theta double dot plus 2 mlx x dot theta dot is going to give me minus mg L plus x sine theta. So this guy is going to give you the motion that it will going to have some kind of this thing, oscillatory motion. Okay, the pendulum like motion. But what happens is that this guy also keeps on moving like this. So it has having harmonic motion as well as oscillatory motion. So two motion is involved here, which can be represented by this object as well as now this object. Now you can see that this is nothing but r squared alpha. Okay, so this object is nothing but some kind of I alpha, that is my torque. This is x dot theta dot. Now you remember it, x dot theta dot appears where? R dot theta dot. So I have described you, this is corresponds to Coriolis acceleration or Coriolis force. Now it is going to like simple pendulum mgr sine theta. For a small angle it is going to having a theta. So you see in angular term there is a torque, always there is also angular acceleration, that is torque, also there is a Coriolis force. But you didn't have to know all these things. You didn't even realize that torque will appear. The torque has appeared automatically. And this guy, the Coriolis force, if you would have applied the Newton's equation, you would have mistaken that there would be no any Coriolis force, and you have to solve so many free body diagrams to reach all these things. But with the help of this polar coordinate system, I didn't have to do any worry. I just did only blindly mathematics, followed the differential equation, and everything has appeared here systematically. Similarly, the whole thing with true for this one. So here the angular term, so angular acceleration has centripetal acceleration has appeared. This has given the Hooke's law, and the potential, the force due to the gravity. So all these equate to the Newton's second law, as well as the non-referential form, so non-inertial frame, which gives you the torque as well as the Coriolis force. And we also call this kind of a centrifugal acceleration. Also this corresponds to centrifugal acceleration. So you don't have to worry about anything. So the r hat, the acceleration with r hat, acceleration has two components, r hat and theta hat. So this guy over to centrifugal acceleration and this guy over centripetal acceleration. So the centrifugal acceleration also arrived here. For centrifugal acceleration, there is a centrifugal force we all also call as pseudo force, and here the linear force which has also a component of centripetal acceleration, as well as the Hooke's force, as well as the forces from the gravity. So you see the power of the polar coordinate system. So far I have done nothing but apply the Lagrangian, apply the polar coordinate system, and reach the amazing result of this kind of system. Well, so far this to solve this thing, it will really so much problematic is so because this equation has been coupled, because there is x dot also involved, here are also involved. So I will, in my later video, I will show you how to find the frequency for this object also, because it is really interesting to know that the what would be the angular what would be the omega for this system. For that thing, please grasp all the concept, and if you have any problem regarding this, let me know in the comment box. I will help you. Thank you so much. This is Adam Leonardo Cap signing out.